Welcome to QGIS 101 and hello from the Amador Reservoir in Spain. My name is Andres de Jong.
In the previous video, I showed you how to draw reservoir elevation area storage capacity curves in Excel. In today's video, I'll show you how to calculate these curves using a digital elevation model in QGIS. To make it more interesting, we'll be working on a reservoir where part of the digital elevation model stops at an old water surface. We'll be using QGIS 3.16 and also a bit of Excel. And like in the previous video, we'll be working on the Kajaki Reservoir in Afghanistan. During the year, the reservoir will either fill up or empty of water depending on the balance between the inflows and the outflows. If we can measure either the elevation of the water level or the area of the water surface, we can calculate the volume stored in the reservoir from our curves. So you can see how important these curves are for water resources management. Here is a 3D view of the Kajaki Reservoir area made from the SRTM30 digital elevation model. Let's zoom in a bit. Note that there's a flat area where the reservoir is located. This represents the elevation of the water level in the reservoir when the SRTM mission was carried out in February 2000. Radar cannot penetrate through water, so the SRTM cannot tell us what the topography is like below this elevation. This is the maximum area flooded by the reservoir on the 15th of April 2020. And here's the situation on the 23rd of January 2022. What we need to do is to decide what is the maximum area which can potentially be flooded by the reservoir. First, we'll make some contour lines from the DEM. Then we'll pick a suitable one to delineate this maximum area, which will then convert into a polygon for the calculations. It does not really matter if the contour line which we picked is way above the current dam and spillway elevations. It's always better to collect too much information than too little, just in case someone decides to increase the height of the dam in the future. Okay, let's get started. The first step is to project the digital elevation model. I've already loaded the SRTM30 meter digital elevation model, and you can see there's a flat area where the previous water surface used to be in February 2000. If we click anywhere inside this flat area, then you'll see that the elevation is 1010 meters. Let's remember that for later. Okay, now this is in geographic coordinates WGS 84, which is not suitable for making any kinds of calculations. We need to project it. I advise you to use an equal area projection, and you can pick any one you like as long as it covers your area. What is important is that the end result looks similar to what people are used to seeing. Okay, not bad. Now let's project our digital elevation model. Right click, export, save as. We'll save it as a GeoTIFF, and we're going to call it SRTM30 underscore and the number of the projection, which is 54034. Press save and OK. It is ready. Now let's just copy the styles from the previous layer. Right click, styles, paste style, and that's it. We have projected our digital elevation model to an equal area projection. The next step is to create some contour lines. So we select our digital elevation model, we go to raster, extraction, contour. Now the interval 10 meters is okay if we just want to do a quick look, but I think we're going to go for 2 meters today, and all the other parameters are okay. Just press run and close. Now this is going to take a bit of time. Next step is to select the maximum flooded area. We've produced a whole bunch of contours here, but we don't need so many of them. Let's filter this a bit. So I'm going to right click here, filter, and I want elevation contours which are greater or equal to 1000 meters and elevation which is less than or equal to, let's say, 1100. Test it and OK. So I filtered out most of these higher contours. And basically what I'd like to do now is to find a contour line that is below the top of this ridge here. So that's obviously too high. So let's right click and let's change this to black so we can see it more easily. Press OK. And let's change our filter as well. Right click, filter, and we're going to make it less than 1080. Press OK. All right. So you can see there's bits of the mountain starting to poke out above 1080 meters, but that's still too high. Right click, filter, 1060. OK. And that is already looking better. Basically, I don't want to have a contour line that's still showing here. We want to have a clear break. So right click, filter, let's make it 1050. Press OK. Okay, so that's looking good. Basically, if we take the 1050 contour line, then in theory we could fill up the Kajaki Reservoir up to that level without it going over the top here, but of course we might have to elevate the dam and the spillway a bit. So this is all very theoretical, but basically I'm just looking for the magic contour line. So let's do our final filter. Okay, so this now is our 1050 contour line, which is the maximum that we could envisage flooding this reservoir to if we made a significant elevation of the dam and also of our spillway here. The next step is to edit our contour line. So I think what we'll do first of all is to save it, because it is still a temporary file, as you can see by the little bug symbol here. So right click, export, save features as. We can save it as a shapefile, no problem, and we're going to put it here, Kajaki contour 1050, save. But please be careful, the projection should be the same as our digital elevation model. Press OK and extract it. Okay, so I'm just going to switch these off, but we can keep these as well if you like. So what we need to do is to edit this contour. Let's just switch off the digital elevation model and have a look at it. Basically what we'd like to end up with is a polyline that goes right around our project area, but without these bits and pieces sticking off the end. So we're going to edit it. First of all, let's make sure that we have the right tools for it. We need the advanced digitizing toolbar and the digitizing toolbar. Right click, toggle editing, and you'll notice that all these tools are now illuminated, which means they are active. We're going to select our contour line, and I think the first thing we'll do is we'll try to chop off this bit up here. Let's zoom in on this area, which is where the spillway is located, and we're going to use this tool here, which is the split features tool. So let's click and right click. Notice how the selection has gone away. So let's just select this one and zoom out. That's safely outside of our project area. Hit delete. Now you see there's lots of bits and pieces left over here. We will just go and select them like so and hit delete. And any bits and pieces which we don't need, we can just delete them. For example, this. Okay. This contour line here is still connected to the rest of it. So I think what we'll do is we'll chop it right here. So zoom in, use the split features tool, click, click, right click. And you notice that actually what is selected is what we don't need. Hit delete. Okay, it didn't like that. Select, delete. And now we can also select all these bits here at the bottom and delete. Okay, it is looking good. But basically what we want is a complete polyline around our project area. We still have some circular regions here. Let's chop them as well. Select and splitting tool. So starting from here, right click. Okay, let's see if it has split it in the correct way. Hit delete. And let's also split this one here. Select it, splitting tool. Okay, looking good. Of course, there's some gaps here now which we should fill. So there's different ways of doing this. Let's use add line feature. But before we do that, let's switch on our little snapping tool. It should snap to active layers, to the vertices, and 100-meter radius is fine. So when I come here, click, click, and right click. And the elevation is 1050. I don't know about the other things. Press OK. All right. And we want to do the same here. So click on the ant, click, right click, 1050. OK. There's still a last piece here. Select the end, click, click, right click, elevation is 1050, press OK. Alright, so I think our polygon should be closed. Let's try to select this area here, and that should select the rest of it as well. Okay, it's looking good. Now what we need to do is to merge it all into one polyline, and this is the one we want. Merge selected features. Click on it. Okay, and let's select it, and let's go to the open attribute table and show selected features. All right, show all features. If we click this one here and invert the selection, what it should do is select all the features which we don't need. Now you can see how they're scattered all over the place here. There's all sorts of bits and pieces. And actually, we'll be very brave now and just hit delete and say yes. They've all gone. Now let's have a look inside of our contour line. There's only one polyline, and we have deleted all of the rubbish that was inside or outside of our polyline. Okay, so that's looking quite good. I do want to run a check on our polyline, so let's check the validity of the geometry and press run and close. Okay. So if I just switch this off, okay, it thinks there's only valid output. That's a good thing. There aren't any errors, so we can just delete all of these temporary files, and I'm going to save this one. So first of all, stop editing and save the edits. Okay, I'm quite pleased with that. The next step is to convert our contour line into a polygon. Okay, so what we'll do is we go to Vector, Geometry Tools, and we want lines to polygons. And let's just run it. Press close, and let's just check that it looks okay. I'm also going to run a quick check on it. So this polygon, I'm going to export it also as a shapefile, and we can stick it in the same location. Let's save our project while we're here. The next step is to extract the digital elevation model under the reservoir. So let's select our DEM, that's this one here, and go to Raster, Extraction, Clip Raster by Mask Layer. And our input layers, of course, are DEM. The mask layer will be our polygon. And the target CRS should be the same. And let's run it. Okay. No data outside, and elevation data inside of our potential flooded area. Excellent. Temporary file looks good. Let's save it. Export, save as. It can be a GeoTIFF. We'll get rid of our temporary layer. The next step is to calculate the elevation area volume relationship. Select the digital elevation model underneath of our reservoir project area, go to Processing Toolbox and look for volume. The tool we want is Raster Surface Volume, double click on it. Our input layer is our DEM. Our base level will be the elevation below which we want to have our volume. So let's start with the lowest level, which is 1010, the elevation of the water surface of the reservoir in February 2000. Now there's 4 methods we can use. The one we need is count only below base level. And we can press run. You see that the results are shown in a report, which you can open. However, I don't think it's very useful because it doesn't tell you what is the base level elevation. So I recommend that you do not use these reports, just switch them off, skip output, and just run it like so. And then what you can do is you can copy the result directly from down here. So this is for 1010 meters, copy, and I've prepared an Excel file. So we just paste it in here, and it's a little bit cumbersome, but double click, Control X, double click, Control X, and Control V. Okay, area, pixel, and volume. Copy it and paste it. The next elevation which we want is 1012 meters, because we're going to do it every meter. So just click on Change Parameters and make that 1012. Run it. Okay, so here's our output. I don't think I've done any copy-paste errors because the relationship looks quite smooth. We have our elevation volume curve here in orange and our elevation area curve in blue going the other direction. Now be very careful because this refers only to the volume above 1010 meters. Remember, that was the top of the reservoir when SRTM was being measured, and this is something that we still have to add the volume below 1010 meters, which I'll show you how to do in a minute. I mentioned at the beginning of this video that we don't have any DEM information below 1010 meters, as this area was covered in water during the SRTM mission in mid-February 2000. Normally what we should do is to carry out a bathymetric survey of the reservoir and make sure that we can tie it to some control points which we can compare with our digital elevation model. A survey was carried out in the Kajaki Reservoir in 2006, and you can get the elevation capacity data from USGS report SIR 2007/5148. I'll leave a link in the description below this video. In the section on conversion factors at the beginning of the report it says, elevation refers to distance above an arbitrary datum. Presumably this was set up when the dam was built in 1952, and there is no easy way to transform this datum to the datum used by SRTM unless you have the exact coordinates of the control points in both coordinate systems. The next step is to try to combine the 2006 survey data with the SRTM data in Excel. Okay, here we are in Excel. On the left, you can see a table with the 2006 data from the USGS report, and on the right is the SRTM data, which we've just calculated in QGIS. So please note that we have an arbitrary elevation for the 2006 data and an SRTM elevation for the current data. Now, if we plot them against each other, then the two curves do not match at all. In blue we have the 2006 data, which is has a much shallower gradient than the SRTM data. So one thing that we need to do is to correct for the elevation. So the way we do that is we have to basically guess at what the difference is between SRTM and the 1952 datum. So let's put in 20 meters. What happens now is that 20 meters is added to this column, to the corrected SRTM elevation. And if we look at our chart, you can see that it's looking a bit better because the lines are getting a bit more parallel, but there's still quite an offset. And one reason is, of course, that we have got to correct for the volume of water below 1010 meters, which is not included in the SRTM model. So we go here and look for the closest number to the spillway, which is at 1033.5. Paste it in here, and let's do that again just to be sure. So what's happened here is that a volume correction has been applied so that the volume at the spillway is correct for both data sets. And if we look at the chart, there we go, the two curves will cross at the spillway elevation, but you can see that they're still diverging higher up in the system, so that's not so good. We can use a smaller elevation correction, for example 10 meters, and do the same thing. I'm looking for some volumes close to the spillway. Put it in twice. Okay, so now it's actually a bit steeper than the 2006 data. So then we know that our elevation correction has to be between 10 and 20 meters. Now I've tried it several times, and I think 15.5 meters is the best possible combination. Let's correct for the volume below 1010 meters. And let's just do that again. And there we go. If we zoom in a bit on our chart, you can see that the overlay is pretty fantastic I'm very happy with this result, and what it means is that this is a way of trying to find out how we can shift between this 1950s datum and the SRTM datum, and that means we can then also use these curves to estimate volumes using other sources of information, which I'll cover in another video. So what I've done now is I've taken all the data from 2006 up to the spillway, so that's all this stuff, and put it in this table here. So up to the spillway elevation is the 2006 estimates, and below that I'm using the SRTM estimates. This is what our area capacity curves look like. So in blue is the storage capacity with elevation. Of course, some of these numbers up here are very fictitious, but it doesn't matter, it was just for the principle. And here we also see the estimated area in red, and you can see that it is steeper at the beginning and then starts to become more gentle as the topography widens up in the upper reaches of the reservoir. I hope that you found this video useful. If you have any comments, please let me know in the comment section below this video. Thank you for your attention, and see you on the next video.